We are ready to go, Dale.
Just next. It's heat season again, and this is always a good topic to kind of kick the year in to gear. If you want to use all of this or pieces of it for your folks, please do. If this wasn't such an issue with us losing people each year due to heat stress, we won't have to go through this. It's a nationwide outreach campaign to try to reach people who are working outdoors. And next. We're not going to hit everything, but what I did is I went back and I took the presentation that I had in the past, rebuilt it to actually follow the current OSHA web page. So if you need to actually look at any of the stuff, it actually follows in line with the OSHA web page. So, and we've actually changed the way some of the stuff's on the web page, and that's why I thought it would be important to put this in that format as opposed to what I had been using in the past. Next. We're concerned with the high heat and temperatures that we get each year, and it just seems like last year was hotter than previous years. It just seemed that way to me. Maybe I'm getting older, but we definitely have to be concerned about this, especially with folks working out in the sun, doing different strenuous tasks, and the different diseases can be quite deadly. A few numbers from previous years, on average about 1,500 people die each year due to excessive heat. Work-related folks, we lose around 30 to about 47 each year. And I know in our backyard, we've lost 3 people in my time in this particular position. So one was a roofer, one was out in the field working, and I forget who the third one was, but we've lost 3 in the Harrisburg area alone. And I looked at some of what OSHA has put out. The highest rate has been roofing folks. They're number 1 on the list, followed by, believe it or not, folks working out on a tarmac at an airport, car dealers, which was interesting, and then labor contractors and crew leaders. So, and then poured concrete foundation and structural contractors. So, and then landscaping. So, I mean, it affects anybody who's pretty much working out outdoors. And how does this all happen? Well, basically, the body loses its ability to regulate itself. There's something called a hypothalamus that controls our body's temperature, similar to the thermostat in our car. And if it can no longer regulate our temperature properly, then that's where things start to fall apart for us and we get ill. And this can be prevented. There's things we can do to try to get ahead of this, part of which is knowing what the signs are, what you need to do, and then our favorite little slogan that we have for this time of year, that's water, rest, and shade. Even though there's other things we can do, those are always the cornerstones to help pull this whole program together. Let's take a look at the next slide. And what I want to do is just visit worst case scenario and then just back it off into the different types of heat illnesses that people can experience. And the worst, of course, is heat stroke. Nobody wants that. That's the worst. Sweating stops. Body can no longer rid itself of excess heat, and this is the worst possible one. And I have the signs listed out here for you. Confusions, slurred speech, loss of consciousness, seizures, heavy sweating, hot, dry skin, high heart rate. And if somebody experiences this, immediately make sure you get them help, call 911. And all 3 of the cases in South Central PA where we lost a worker, they actually did try to help them. They got them to the hospital, and they all died within about 3 hours of being at the hospital. So once the body gets overburdened, pushed too far, it's hard to bring it back. Heat stroke is nothing to mess with, and this is definitely something you need to go over with the guys. And one of the problems is a lot of times people just don't want to admit that they're having problems. So, but if they're having an issue, they definitely need to bring it up before it actually turns into an issue. Our next one is heat exhaustion, and that's our body's response to the loss of water and salt from heavy sweating. And we have the symptoms here as well, the fatigue, the headache, nausea, vomiting, dizziness, lightheadedness, weakness, irritability, thirst, heavy sweating, elevated body temperature. So that one's important as well. Heat stroke's the worst. Heat exhaustion can be bad for you too. Then we move into ones that don't actually involve the body's core, but that would be the heat cramps, loss of body salts, and of course you get tired muscles then because your body needs those salts. And as you can see, it all lines up with the muscles here. Signs include muscle spasms or pain, legs, arms, trunk. And then our last one, heat rash, prickly heat, skin irritation, bumps on the skin, neck, chest. So heat rash, there we go. Then we have another thing to consider, and that's each of us. As we get older, our bodies change, we go through different things. Maybe we pick up some diseases that we never had before, or maybe we're just getting a little bit older. I know myself, I fight with the first one there, that body mass index. If we have a higher body mass index, obesity, that can be a risk factor. Diabetes, high blood pressure, heart disease, lower level of physical fitness, certain medications, these diuretics that take the water out of our system, or other drugs, medications, alcohol use. One of our 3 cases in South Central PA, the person had been drinking the night before, depleted themselves of water, and that's pretty much what caused their issue. And illicit drugs can also be an issue here for folks. So I know myself, I have fought with a couple of the ones on this list, and I've been able to actually push them back with good exercise, diet and exercise. My blood pressure was going up. I got that back under control. I'm trying to lose weight. So, I mean, personal risk factors are definitely an issue. What I thought was interesting, what OSHA talks about also whenever talking about personal risk factors, they talk about physiological monitoring of a person. That's a direct measurement of a person's response to heat stress. I haven't seen anybody do that, but I think it's conceptually very interesting that you can actually monitor a person and how they're doing right there on the person. So maybe we'll see more about that as time goes on. Are any of you doing that? Actually monitoring the actual worker?
I'm monitoring myself.
Okay.
My watch tells me if I'm acclimatized to the heat. I'm at 84% as of today.
So how does your watch do that? That's interesting. I didn't know the watches would do that.
I have no idea, other than it pops up and it reminds me, hey, continue to exercise and do activities in temperatures greater than 72 degrees, and it gives me a percentage breakdown every time I improve.
That's interesting. So even though the watch is on your body, it actually can tell the temp. Oh, it probably goes onto one of the apps or whatever to see what the temperature is outside.
I believe it pulls the temperature outside and it checks your temperature along with the activity that you're doing. So it has a combination of things.
That's interesting.
Yeah, the technology is really. It also, and again, the technology is crazy. It also tells you your oxygen uptake. You can run it through the evening, and it tells you how well your saturated oxygen levels are.
That is interesting. So it's almost moving toward where you can tell if you're getting overexposed to heat.
Yeah. It will remind you to drink. I know that. So you have to input that I how much fluids that you drink and things. But yeah, these watches today are really becoming quite advanced.
Although it's not being used much, the fire service has had technology like that for a good long time. It measures firefighter heart rate, temperature, and things like that, so that you know if they're getting in trouble.
This is good. This is real good. This is going to help actually bridge the gaps on some of what it takes to help people. That is fantastic. That's good to hear, Kevin. That's good to hear. I thought it'd be good to mention this other factor here too. And you mentioned your watch said you're partway there. Are you acclimatized? Are you ready for the heat for the year? And some of these numbers are pretty interesting. Half of the heat-related deaths occurred on the very first day of the job. That's really interesting. Or 70% of the deaths on the first week. And as we start moving into a warmer season, or maybe you're picking up more workers for different jobs, or folks, maybe they were doing one type of task and now they're doing something else where they're exposed to the heat, definitely make sure they're ready to do the work. I would definitely just find out where they're at when you're bringing new people into a task, just to make sure that they're ready for it, because I mean, those are some pretty big numbers. If you look at it, half on the very first day of the job, 70 heat-related deaths on the first week. I mean, if there's an area to focus, that's definitely one of them here. So what can you do about it? And you need a plan for just about everything these days. And a heat illness prevention plan. What are some things you can put in there? It's not me.
Okay, I'll see what I can do here.
Okay. And the first thing with that,
Dale,
okay.
are you there?
I'm back. I was muted there for a minute.
Okay.
With that plan, what do you do with any other hazard? I mean, it's the same recipe for everything that we do these days, and it's a good recipe. First, you do the assessment. Figure out where you're at. Where do you have issues? What can you do better? Then the next thing, once you figured out what you have the controls, engineering, administrative controls. And then since we've identified that folks that aren't quite ready for the heat, what precautions are we going to take to protect them? And then we go back to our favorite three, water, rest, and shade, and then relaying those expectations to the worker through some form of training. And I mean, this is pretty much our safety recipe. I use it all the time, and it fits in this particular case too. It fits with the heat stress. And then the next piece of this is the day-to-day supervision, because you can have the best plans in the world, but if nobody's instituting it, or if people don't understand the expectations, it's going nowhere. So it's a day-to-day supervision to control those heat hazards, recognizing symptoms of folks, administering that first aid when needed, and the medical emergencies, notifying them. So, I mean, it's these two pieces. I don't care whether it's heat stress or any of your other programs. This is pretty much what makes it all kind of fall together. So let's get into the recognition portion of this whole thing. And what OSHA has done is they've come up with a little recipe for actually figuring out whether we have a problem or not. So we're going to work toward that. But there's many things that can affect the heat. And this is part of the recognition piece that the person in the field has to figure out. They need to look at their indoor activities, their outdoor activities. You might need to look at the air temperature, the amount of sunlight, just what's going on these days. Are people working in the shade? Do you have any external sources of heat? Do you have an oven there of some sort heating something, or tar buckets, or some external heat source that might cause problems? Is it in an enclosed space where people aren't getting fresh air? And then looking at the physical amount of activity folks are going through. Are they moving slow, or are they actually getting into their type of work, or do they have something they're trying to dig up out in the outside? Whatever the case may be, looking at that. And then, of course, what clothing and protective gear people are going to wear. But it's just going through that whole process. And this is what I call my such as chart, because there's other things you can add to this, but just looking at where you might have issues. Now, one of the things that OSHA has also put together, and I did not include any of this, but OSHA has our technical manual, and NIOSH has a manual, and I need to actually, I'm going to add a slide on that actually, now that we're talking here. A slide pulling up the OSHA technical manual as well as the NIOSH manual to help you actually with some of this determination. So we're going to throw those two things in. So good pieces here. Then we also have what affects each person, our own risk factors, how acclimatized we are to the heat. And so that's on the recognition side. So we've talked about what's in the environment. Then we also have our own bodies, what our body generates for heat. I know if you get enough people in a room, you better turn that air conditioner on because we put off heat. And if you're outside, that same heat is what adds to what's in the environment to actually bring a person down. So definitely something to look at, how much we're generating ourselves. So what OSHA has done, they came up with this little process here for the determination as to whether it's too hot or not. And now this is a little bit where I deviated from the web page, because at the end they get into this 5-step process and they talk about all of these first. I thought it made more sense to talk about the process and then talk about each of these elements as we work our way down through. And so let's just go down through this process that they have listed on the web page. First, you need to estimate the workload, and there's a table for that, and we're going to look at that, and it breaks it into different categories. Second, we have to come up with what's the environmental heat, and there's a couple ways of doing that. Next, we need to look at what somebody's wearing, where it might affect that heat buildup in the person. And we need to figure out if the person is ready for the heat. Are they acclimatized to it? And then finally, there's a table that tells us whether or not we're going to have a problem or not. So that's kind of the roadmap. And what I want to do is just kind of work my way down through these. So on this next slide, we actually have a chart. And I think we've all seen this chart back in the day when we didn't have some of the apps on our phones or whatever. We would actually go out with a sling psychrometer or whatever and take some of these readings and figure out where we're at for our folks. And that's still good information, still a good way to go. There's nothing wrong with that at all. But that's what we used to do a lot. Our next slide here, OSHA has actually done some of the work for you for folks working outdoors, and that's our app. And you can download the app on your iPhone, your Android, and it will basically use that same chart, but it actually pulls your local information. Now, the limitations in using the app is it's only good for outdoors. It may not be applicable in your particular situation, or maybe there's no weather tower near you, and the nearest tower is 20, 30 miles away. Maybe it's not exactly pertinent to what you're using, but at least it's a tool. So it has its limitations, but it is good too. So that's a little bit about the app. And then here's some indoor and outdoor activities. Agriculture, if you're doing outdoor construction work, roofing, landscaping, or whatever, that app might be good. But once you move inside and you have these extra heat sources, whether maybe somebody needs to heat something on the job site, or they're in an enclosed room or whatever, then it may not be as pertinent. So indoor would be different than the outdoor work. So I mentioned the very first step of that process, and the first step of that process was to estimate the workload, and that's our very next slide here. That's coming up with your metabolic heat and workload, and that's basically your physical work activity. And you see there's 4 categories for this: light, moderate, heavy, and very heavy. And then generically they list out some examples of each here on the web page. Now, if you actually went to the web page, and what I'm going to do is put this link in on the next slide here to this table, and this table actually gives you different values for different types of work that falls into those 4 categories. Now, I don't have the whole table here because literally it would be about 15 or 16 slides, but I'll put the link here, so you just have to click the link and it will take you to this table, and you can actually get these metabolic heat loads. So that was the first step of the process, coming up with that particular number for that particular work that people were doing. Next, we need to come up with how much environmental heat is actually contributing to the process. And how we figure that out is this instrument today called a wet bulb globe temperature device. I used to have 3 of these where I was a safety manager back 3 decades ago. So they are out there. The price has come down on them. We also used a sling psychrometer to get these numbers. But basically, this measures the air temperature, which is dry bulb temperature. Then you get to humidity, and that's that's your wet bulb. Then you get your radiant heat. That's that little black sphere there, and then air movement's kind of tied in with the humidity part. But that gives you what's called a wet bulb globe temperature. So it's not really a dry bulb temperature that you'd get outside or just the wet bulb. It's actually the three of them all combined, and there's a mathematical formula. You set the instrument, whether or not you're doing work inside or outside, and it gives you a number that you can work with. The third step of the process is looking at clothes, protective equipment that can dissipate heat. And these are different factors. And as it says here in the top of the right column, it says clothing adjustment factor. This amount must be added to the measurement of the wet bulb globe temperature when determining heat stress. So you would add that piece in to your number for what people are working. And then we have a little note here. We haven't seen table 1 yet. As I said, I turned this backward compared to what OSHA has on their webpage, which says table 1 indicates that heat stress is potentially unsafe. So when we look at table 1, we'll be able to then take all these numbers and see where we're at. Do we have a problem? Don't we have a problem? And then to simplify things, OSHA came up with this table 2, and it's basically which takes into account the clothing adjustment factors. Or you can go to the very next page and there's this heat stress calculator, and you put different numbers in, different circumstances for each employee, and you can find out what your numbers are. You hit submit, and then it comes back with your heat stress result. And in this particular case, it's below the limits, but if you change the factors, you could be above the limits. So that's kind of how OSHA put that together to help. Now let's take a look at table 1, and this is where it all falls together. And table 1 here, this is our effective wet bulb globe temperature reading. So this isn't just a temperature thermometer outside. This is that device. But are you below 70, 70 to 77, or above 70? And you can figure out what type of work people can do, whether they're prepared for the day or whether they're not prepared for the heat. So that's the process that OSHA has. So now that you've figured out where you're at with the heat, where do you go from here? Well, maybe you can make some adjustments to your work site to actually fix things, to make it better for the workers. And so how would you do that? That goes back to our controls: engineering controls, work practice controls, PPE. And what I have here, and I'm not going to go through them all, but there's some engineering controls, different ideas that OSHA has on their webpage. Maybe you can get workers out of the heat for their breaks, maybe into an area where you have an air conditioner, maybe that's back at the office. And that's really a challenge right now because with the COVID, you can't put everybody in the trailer. So maybe it's a scheduling thing where this particular group, they can spend a little bit of time there, and then maybe another group. It's a real juggling act with COVID right now. Maybe you can put some cooling fans throughout the job site. If you have a heat source, maybe there's something you can do to block it somehow. So just some ideas. What are some of the things you're doing out there on the engineering side?
I think
Well,
they're
that's all
using.
right.
I think they're using the breezes. I don't think.
Okay.
No one's weighing in.
Well, we've got cooling stations on some projects. We sent out a heat awareness training type thing, and our Maryland team really jumped all over it. And they have established cooling stations in different locations of the projects. Water rest.
Is that the water misting?
Yeah, we have a couple water misting fans. We have some pop tents, with markers, designated areas in basements. And we've asked the subcontractors to maintain and supply their own drinking water. And part of our pandemic safety officer's responsibility is to make sure that they're following those rules. They're not, laying water all over the place and basically making a mess. But predominantly finding locations to set up additional shade, fans. Project yesterday actually had some cool air being forced in. So those are some of the things. What we've found is if you don't secure those misting tents really, really, really well, or take them down every night, they grow legs and they also get blown away.
You know, I'll just throw this in just so that you guys are all aware. You know, when you talk about, you know, wetting things and face coverings, and we're in this unique time, you don't want to get the face covering wet. That actually will increase your risk of getting the virus on the face covering. So you know, you'll have to educate workers on, they may have to change their face covering throughout the day, but they should not be wetting that down and then putting that on their face.
That's good, Kevin. I never gave that a thought. Yeah, we have two hazards here, and just trying to make sure it all links together without causing any new problems. That's excellent. That's a good point.
Well, and it's tough too. I mean, depending on how high heat they're in, I mean, they're sweating anyway, so it's continuously getting wet. So then, therefore, the guys are going to have to clean them, like Kevin said. But, you know, some of the guys have said if they're just in some of the misting fan areas, no sooner they're back out there and they're working again, you know, in a matter of a few minutes, again, depending on the temperature, they somewhat dry out on their own as well, too. It just depends on how close they get, how long they're there, and how soaked they get. But, you know, I've heard that they're struggling with the issue of just the sweat containing in their mask as well. So, yeah, they're going through multiples a day. The other thing that we've done for a lot of our guys that are just continually working outside, which masks don't meet the full CDC requirements, but it's better than nothing, is just buy the handkerchiefs, the bandanas, so that they can tie them around their head, and then they just kind of have the you know, it hanging there in front of their face, and then therefore there's a lot more air circulation, and the sweat isn't necessarily all absorbing into that bandana itself. You know, it's really not any different than a face shield. I mean, it still has room for everything to hit and kind of drop in front of them, but, you know, it still catches some of it. But it's tough trying to think of ways that, you know, guys can at least stay cool depending on the conditions they're in.
Phil, you and I were talking yesterday. I know that others might have the same issue, but you were saying about OSIP, you can't just use a face shield. You know, they still have to have the face covering.
Yeah, our OSIP carrier that we're working with won't allow that at all. Even with a doctor's note, if somebody says that they have some medical condition that won't allow them to wear a mask and that they need to wear a face shield, they won't accept that, since the CDC doesn't have any written regulations, policies, requirements about it. So they basically tell them they can continue to work, but their employer has to send them to another project. They can't be on that OSIP project. So that is the struggle that we're dealing with on that job. And it's all outside concrete walls. You know, so their guys are doing form work all day long in the heat. There's no shade on site whatsoever. So, I mean, we've done exactly what Adam mentioned. We have pop-ups. Corey actually came up with the idea of putting pop-ups with the canopy walls up, which we actually had 2 of them in stock in our warehouse, to where we put a portable air conditioner in there. So, you know, it has the canopy cover, then it's got the walls on all 4 sides, and we can have an air conditioner running in there, aside from the job trailer, so that people can go in there and space out and, you know, kind of cool down a little bit and maintain that 6 feet distance from one another as well. We did buy a misting line, like a condensation line, because the rebar is not far enough above their head to kind of, it just got delivered yesterday, so we didn't get it out there yet, but to put it up above where the guys are working, so that it can kind of mist down on them some as well. So that's something we're looking at. But I I think Adam said it, you really do got to make sure you kind of buy this stuff ahead of time. Otherwise, it's going to take a few weeks for it to get delivered.
I thought I had something for you on the face shields, because I know the state, they allow that. But then OSHA had that FAQ, frequently asked question, that just came out on the 10th of June, or around then. But in reading this, I'm not seeing what I wanted to see. It says, this is one of the questions on should workers wear face covering while at work? But I get to the one little question here, and it says where cloth face coverings are not appropriate in the work environment due to certain job tasks because they could be contaminated or exacerbate heat stress, employers can provide PPE such as face masks and or surgical masks instead of encouraging workers to wear face coverings. Like cloth face covering, surgical masks and face shields can help contain a worker's potentially infectious respiratory droplets and can help spread the limit of COVID to others. But that one piece of sentence, such as face shields and or surgical masks, instead of encouraging workers to wear cloth face coverings. So I don't know if that would help your OSIP folks that OSHA actually put this in an FAQ.
Well, we talked to them about it, but the issue is that CDC doesn't have any guidelines on it. So their push is that they know that the state and other organizations do, but they're following all the CDC guidelines. So unless the CDC has addressed it, then they're not allowing it to take place.
And I haven't found anything in the state. Well, did you find anything, Kevin? I haven't found anything in the state.
Dale and I talked about this because it's been such a buzz topic. There is some guidance for healthcare workers, but it's really around work practices, and it's very specific to the medical side. So it doesn't really, I don't think it actually helps you out at all. But it talks about face shields and the sensation of, when you wear these respirators, you build up that humidity level around your face, and it gives you the sense that you're hotter, and it becomes uncomfortable. And so, it kind of gives you some guidance on what to do. But, it is one of those things where guys are going to complain a lot about it. It doesn't necessarily, and unless, Dale, you found something else than what I have had or what I've found, it doesn't necessarily increase your core body temperature, but it does make you uncomfortable.
I did talk to NIOSH, and they're looking now. I believe something when I have it in hand, but they're looking to put together a document on heat stress and the wearing of N95s. So when I get that, you definitely will have a copy. I'm not too sure where they're at with the development of that, but I know that they've talked about making a document like that.
I know one of the things that has come up as a solution for this, but you'll have to look at your work practices, and I don't think it'll work in a situation where you have to follow OSIP. You have those kinds of things. You can, if you can get them, if you can get an N95 with the little cartridge there, that little opening, that vented area, that can help lower the humidity levels inside of the mask. But you then have the droplets that escape, which really defeats the purpose of these things. But you can't usually use those in a medical setting, but maybe with your workers on a construction site, you might opt for that. But again, I think those are going to be really difficult to get.
Very good discussion. Thank you. Thank you all. On the control side, and these lists that OSHA have, they're not all encompassing, but there's a lot of good things in here, such as starting earlier in the day. Maybe you're a roofer, you're paving a road, whatever. Maybe you can start earlier in the day and avoid the heat, or somehow working with your shifts. A lot of ideas. There's a lot of different scheduling ideas, work controls, work practices. We talked about some of them, and I thank you, Adam and Phil, for some of the things you've thrown in. There's another one here. Let's go to the next page. Reducing physical demands. Is there a way to do a job without having the workers put as much in it in a hot summer day, rather than trying to dig it out manually? Can you get a backhoe in there or something? Is there or rotating workers? There's many different ideas here. Encouraging people to drink the proper amount of water. I didn't realize your wristwatch would tell you to do that. That's fantastic. Watching out for others. I mean, these are all good controls. The next page we have different ideas we could add to this list. Good thing. Avoid hot beverages. All good things. The PPE side, I don't really see a lot of this being applicable to the construction so much. I see the insulated suits in foundries and reflective clothings, as well as those reflecting face shields. But the cooling neck wraps might be an option. But you already have something on your face for the COVID. So, is anybody using the neck wraps in addition to a face mask?
I'm kind of curious of the same thing. I know I looked at them. I forget what company it is, but somebody had them. I think I saw it on Airgas's website. Maybe it was another website. And I mean, they were like $5 a piece, and they said they lasted up to 4 hours. Especially now that we got on job sites. I was thinking it'd be, easy for the guys to continue to keep that wet and applying moisture to it so that they can continue to use it throughout the day. But I don't know how well they work.
I know in past safety meetings, somebody mentioned in the past that they were using these. Anybody remember who that was?
I've handed them out to our guys, and I don't know, their response was kind of middle of the road. They work, but it's like a gel inside. Once you make it wet, it's like a gel that holds the moisture in. So they didn't rave about them, but they were all right.
Okay. Never hurts to look. So if we were to summarize some of these ideas, make sure folks are getting enough water, enough rest, away from the heat, and some shade. And I mean, these tents, they're out there, it gets people out of the heat. It's a good thing for the shade side. Let's talk about getting workers ready for the heat, acclimatizing them. We looked at how many incidents we've had. First day of job, 70% during the first week. So this is probably one of the biggest things we can do to help people get ready for it. So the question is, who do we have to worry about the most? And as it says in the next slide, is new workers, temporary, people who aren't used to working out in the heat, making sure that they're acclimatized, getting them used to it, getting them built up for it. So what are some strategies we can use for them? Scheduling new workers for shorter amounts of time in the heat, giving them more breaks, giving them training, monitoring them closely, maybe assigning them a buddy, allowing them to stop work if they have a problem. And this is really important. If somebody is experiencing any heat stress symptoms, don't leave them alone, because when you come back, they may not be good. So don't leave them alone if they are having issues. Now, I thought it was interesting, NIOSH and on the OSHA page, they have this rule of 20%. And what's on this right here is, and it says the first day, 20% of their normal duration the first day. The new worker should only work about 20%. And then increasing that by 20% each day until the person's up to full speed, just to get them used to the heat. So I don't know if there's other things they can do to get out of the heat, but just working them up to the point where they can actually work in the heat. OSHA also says It might take up to 14 days for some folks to get up to speed with heat stress for the acclimatization. So I thought that was kind of interesting there. On the, let's back up one slide. Okay, immediate actions. I would go over this with the workers to make sure that they know their expectations. But if they have a problem, if they're having trouble with heat exhaustion, heat stroke, make sure they know that they can call their supervisor to get help. Somebody needs to stay with that worker if they're having problems until help arrives. During that period of time, cool them down, get them in the cool, give them some shade, maybe some fan, some misting, some cold water, but whatever, get them to where they need to be. Now, if it looks like they're going to go unconscious or they're having issues, you may not want to have them drinking at that particular point, but this is important, that if somebody's having issues, you take immediate action. If it is that heat stroke, you should probably call 911 immediately so that it doesn't get out of control. Those are immediate actions.
Yeah, I'll jump in here too. One of the things as part of the first aid CPR training that we do, you want to try to cool their core body temperature down, and what you can do is have them lie down and you can pour cool water on them. Slowly pour that over their torso, and trying to get them to cool down and fan them too, just to, again, give them assistance until the EMS arrives.
Yeah, it talks about applying ice packs as well. Obviously, you don't want to put it directly on the skin, but if you have a towel or something, you can grab a bag of ice or some ice packs in that towel and stick them in certain areas to keep that core temperature down. Like Kevin said, is also something they suggest.
Yeah, the suggestion is in under their armpits and their groin. So, you want to try to get it around their torso the best that you can.
Excellent. But then the typical training, things to go over with them. The types of heat stress, go over the different types, how it's important to immediately providing first aid when somebody does have an issue, how to contact emergency services. And I know with the new confined space rule, it's not good enough just to say, hey, we're going to call 911, but you have to make contact with the local 911 folks, the local emergency responders, and make sure they're on board with what you're doing with the confined space. When you're talking to them, it may not hurt to ask some of these other questions as well, what they can do, what the response time would be to your site. I mean, it's all important. Actions that they can do to reduce their heat stress with these controls, whether it be engineering or work practices, what they can do there. Importance of being acclimatized and job factors, fluid replacement. I mean, all good topics. You need to take breaks in cooler areas, all important. Okay, let's hit the first aid piece. And whenever I talk about first aid, I always try to go back to what OSHA says about first aid. And it's in the standard, but then they don't actually describe the word proximity. It says it has to be in close proximity, but there is a letter of interpretation that OSHA has that defines what they mean by proximity. And it says where the first aid standards do not prescribe a number of minutes. OSHA has long interpreted the term near proximity to mean that the emergency care must be available within no more than 3 to 5 minutes from the workplace. Medical literature establishes that for serious injuries such as those involving the stopping of breathing, cardiac arrest, uncontrolled bleeding, first aid treatment must be provided within the first few minutes to avoid permanent medical impairment or death. Accordingly, in workplaces where serious accidents, such as those involving falls, suffocation, electrocution, amputation, are possible, emergency medical services must be available within 3 to 4 minutes if there's nobody on site who's trained to render first aid. So, and that might be one of the questions you ask your local responder when you're setting up a job site. How close can they be? How long is it going to take to respond? And that might help you decide whether or not you give your folks first aid training. So, back to the first aid piece. get the person to a cooler area like we talked about, and immerse the person, pour cold water on them, remove those outer layers of clothing, the ice cold packs, using fans. I mean, they're all good. There's probably no limit of what you can do to help somebody for heat stroke. And of course, don't leave the person alone and call 911. If they're having heat stroke, you don't want to lose somebody, that's for sure. So what does OSHA have to help you? We have our webpage. It has a lot of good information on it. And on the next slide, we have information on our little booklet that we've put out called the Heat Illness Prevention Training Guide. It's a great book to help you. It has different handouts in it, different posters, a couple of the recommendations that's made. If you see you're going to have to hit a lot of information from your workers, maybe break it in a couple of different sections, maybe going over the effects of heat, how to respond to heat, and then first aid. Just some thoughts for you, but that's in the lesson plan. That's a good document. We also have these publications that are available to you. You can download them. We have community posters, and of course we have OSHA to help out as well, to help with explaining things. So don't forget, water, rest, and shade. Just keep drilling that into everybody's head. And that's pretty much what I had. You're welcome to this. I'm going to make a few little changes and add the NIOSH reference, as well as the website for that one particular table, so you can click on it and go right over there. That's all I had. Other questions?
I just think, and Kevin can probably touch on this too, would be worth adding. I mean, we talk about like the heat stroke and the exhaustion side of things, but we've had one or two cases in the past where seizures have been caused related to heat illness, and depending on the person's past medical conditions as well too. So, that's something that you might want to make sure your guys are trained on as well. If somebody is having a seizure, because whether it's heat related or not heat related, just making sure again that they know what to do in that type of situation. I mean, there's not much first aid treatment you can do there, but just keeping the area clear around them so that they don't knock something onto themselves that could cause them another injury. Depending on how long the seizure lasts, they may need some medical treatment, that kind of stuff. Again, that all goes back to some of their first aid training that hopefully everybody's providing their manpower.
All right, and Dale, you might be able to correct me if I'm wrong on this, but at one point, OSHA was trying to see if there was any correlation between heat stress and cardiac arrest. So just as a reminder, depending on the overall physical condition of the worker, heat-related illness can quickly move towards, or where you'd have an episode that the individual may go into cardiac arrest or sudden cardiac arrest. So you're going to have to be able to be prepared to jump in and do CPR, and if you have an AED, have that available as you respond to anyone that's getting heat-related illness.